All right, ladies and gentlemen, so now we're looking at ionic bond formation and Lewis structures for ionically bonded substances. Okay, so for this one, we are going to be using two elements. We're going to be using magnesium, metal, and oxygen as our nonmetal. We're going to gather a little bit of information about this thing before we get started so that we can draw some conclusions later on. So the first thing that we're going to be looking up, we're going to be looking up ionization energy. Now remember, ionization energy is the energy needed to remove an electron. Okay? So you find your periodic table of data, which looks like that. And then we're going to find where magnesium is. Magnesium is actually this one right here. Okay? So element number 12. The ionization energy is 737.7 kilojoules per mole. All right? So 737.7 kilojoules per mole. Then we're going to do the same thing for oxygen. All right? So periodic table of data. Oxygen is element number 8. So we're going to zoom in on that. The ionization energy is 1,313.9. So 1,313.9 kilojoules per mole. So we can already draw the conclusion that for metals, will have low ionization energies, which we should know from the periodic table unit, and nonmetals will have high ionization energies. All right, so then we're going to move on to electronegativities. Now, electronegativity, remember, is the attraction for electrons. So things that attract electrons strongly will have high electronegativity. Things that attract electrons weakly will have low electronegativities. So back to the periodic table of data. Back to magnesium. Electronegativity, 1.31. All right, so electronegativity, 1.31. And the electronegativity for oxygen, back to the periodic table of data, 3.44. So again, we can draw the conclusion that metals will have low electronegativities and nonmetals will have high electronegativities. Okay, then to show how this works, what we're going to do is we are going to do a little Bohr model for each of these guys. All right, so if we look at a regular periodic table, you'll see that magnesium has an atomic number of 12. Okay, so atomic number of 12 means that we will have 12 protons, right? Actually, let me use a different color because I want colors to mean something here. 12 protons, which means that we will have a positive 12 in the nucleus. All right? Then if we go and look at oxygen, you'll see that oxygen has an atomic number of 8. And so oxygen will have 8 protons, or a positive 8 in the nucleus. All right. Now, since magnesium has 12 protons, when it's neutral as an atom, it's going to have 12 electrons. And so remember, you have 2 in the first shell, then it goes 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Right? So that is magnesium when it is neutral. Magnesium. All right. Then oxygen will have 2 in the first shell. 1, 2, 3, 4, 5, 6, 7, 8. So that's oxygen when it's neutral. All right. So what happens when an ionic bond is formed? A metal will transfer its electrons to a nonmetal. So this electron right there that used to belong to magnesium, now it's going to come over here and belong to oxygen. So now the magnesium has lost an electron. It's going to have a positive charge. Losing an electron gives it a positive charge. Then the oxygen has gained an electron. It's going to have a negative charge. Now, notice that oxygen is still missing one electron to have an octet. Remember, 1, 2, 4, 6, 7. All right? Everybody wants an octet. So, we're going to transfer that electron. Now, look at magnesium. There are 2, 4, 6, 8 electrons in that shell right there. All magnesium has to do is lose that electron and it will have an octet. So that is exactly what happens. That electron right there will get transferred over to the oxygen. And so that electron now belongs to the oxygen. And look at all the different things that happen at that point. So because the oxygen has now lost 2 electrons, it's magnesium 2+. And because of that, we have 2, 4, 6, 8. There is an don't mean to do that. There is an octet in the valence shell for magnesium. That is a stable ion. Because the oxygen has gained 2 electrons, it is now oxygen 2-. And there is an octet for that as well. 2, 4, 6, 8. An octet for the oxygen. And so at the end, what you have is 1 magnesium 2+, 1 oxygen 2-, and they will join together to make the compound MgO, or magnesium oxide. All right, so that will allow us to fill in the blanks on this next part. Ionic bonds are formed by the transfer of electrons from a metal to form a positive cation to a nonmetal to form a negative anion. The positive and negative ions, if you recall from the last one, are held together by a strong electrostatic attraction, because positives and negatives attract to each other. Now, when you're doing a Lewis structure for these things, so we're going to do a Lewis structure for magnesium and fluorine because that's the one in the little homework set. All right? So we know that magnesium is, here. It only has 2 electrons in the outside shell. So we're going to go ahead and do that little Lewis structure there for magnesium. So magnesium, 2 electrons in the outside shell. Then we've got fluorine. Back to the periodic table. Fluorine is over here. 7 electrons in the outside shell and the valence shell. So fluorine is going to have this Lewis structure. Well, magnesium is going to be the one to lose electrons. So the element losing electrons is going to be magnesium. Fluorine is going to be the one to gain electrons. So the element gaining electrons is going to be fluorine, right? Just needs one more to make its octet. And so when we do that transfer, oops, I really shouldn't have put that there, should I? Because that's the final Lewis diagram. Should have put it over here, right? So when we do our transfer, one of the magnesium electrons is going to go right there, okay? So that guy is going to have, if I use my little eraser here, so that guy is going to have an octet now, right? 2, 4, 6, 8. So it is now fluorine negative. That fluorine is happy. That fluorine is stable. It is full, all right? But this magnesium is not. See how it's only got 1 electron in the outer shell and the valence shell? That is not a stable condition. So that right there is going to have to go somewhere. Well, the only place that it can go is another fluorine atom. There's nowhere else that it can go because the other fluorine atom is already full. So that electron right there is going to go to that fluorine right there, making it a fluorine negative. Now, magnesium has lost 2 electrons, so that will be a magnesium 2+. All right? So the final Lewis diagram, I'm just going to check real quick and see how they do it in there. All right. So the final Lewis diagram is going to be magnesium. Let me make sure I'm doing it the way they do it. Okay, magnesium with a 2+ charge, and we're not going to put any valence electrons there because it's lost them both. We know that it actually has an octet on the outside, but we're not going to put them in there. Then fluorine with a full octet and a negative charge, which it does, and there are 2 fluorines because, oops, let me do that slightly differently, because it required 2 fluorines to soak up those electrons for the magnesium. And that is how you do a Lewis structure for an ionic compound.